Tonight we're exploring cosmic crashes so massive they dwarf every earthly disaster imaginable. Entire galaxies, each containing hundreds of billions of stars, are locked in gravitational battles that stretch across billions of years. How can two massive stellar cities slam into each other at highway speeds, yet somehow every single star survives without a scratch? And what happens when our own Milky Way keeps its appointment with the approaching Andromeda galaxy? It is an inevitable collision that's been scheduled for 4.5 billion years from now. The universe stages thousands of these galactic smash-ups right now. Each one reshapes the cosmic landscape and creates entirely new breeds of stellar neighborhoods. These aren't just random cosmic accidents. They're carefully choreographed performances that reveal the universe's most spectacular destruction and creation happening in ultra-slow motion. So settle in. Before we begin, leave a quick note in the comments, where you're listening from, or one thought you're carrying tonight. I read them, and they genuinely help shape future journeys. If you'd like more nights like this, subscribe, only if you enjoy these late-night journeys. Now let's begin. Times Square on New Year's Eve contains maybe 100,000 people packed into a few city blocks. Now imagine something infinitely more crowded. Our Milky Way galaxy contains over 200 billion stars blazing across the cosmic darkness. Logic tells you that when two of these stellar megacities crash together, it should create the universe's most catastrophic demolition derby. Your intuition breaks completely here. Astronomers calculated what actually happens during galactic collisions. They uncovered one of the cosmos's most beautiful magic tricks. These stellar neighborhoods aren't the densely packed cities they appear to be. Space operates on scales that shatter human comprehension. Shrink our sun down to the size of a marble in your palm. Where would the nearest star sit? Not across the street, not even across your city. It would rest 600 kilometers away, roughly the distance from London to Edinburgh. That marble represents our entire solar system. The next marble sits in a different country entirely. Scale this emptiness across an entire galaxy. Even the most violent galactic collision becomes a gravitational waltz. Hundreds of billions of stars glide past each other like ships in cosmic fog. The universe's most polite game of bumper cars. Everyone changes lanes. Nobody actually bumps. We can watch this impossible dance happening right now throughout the universe. The Hubble Space Telescope captures galaxies mid-collision. Their spiral arms stretch and twist under enormous gravitational forces. The dramatic antennae galaxies locked in their cosmic death spiral. The train wreck happening in Stephen's quintet. In collision after collision, the same stunning pattern emerges. Entire galactic structures reshape and merge while individual stars remain completely untouched. What looks like catastrophic stellar destruction actually represents the gentlest possible renovation project. Hundreds of billions of stars change their galactic zip codes without ever meeting their new neighbors face to face. What's the longest movie you've ever watched? 3 hours feels endless when you're checking your watch every few minutes. The universe operates on a completely different schedule. When it stages its greatest performances, every scene takes longer than complex life took to evolve on Earth. Galaxy collisions unfold like the cosmos' most patient slow-motion movie. You could watch dinosaurs live and die, then watch mammals take over, then witness the entire story of human civilization. The galactic collision would still be getting started. These cosmic titans prefer their drama served with geological patience. Andromeda galaxy barrels toward us right now at 110 kilometers per second. That's fast enough to circle the entire Earth in just over 6 hours. This cosmic bullet train could cross the continental United States in 1 hour. Yet it won't even arrive here for another 4.5 billion years. The actual collision will then take an additional billion years to complete. Time becomes meaningless when you're operating on cosmic scales. Computer simulations reveal why these cosmic speed demons move in such theatrical slow motion. Feed the actual masses and distances of real galaxies into the cosmic calculator. The numbers tell the same story every time. Major galaxy mergers require between 1 and 3 billion years from first gravitational contact to final coalescence. The approaching galaxies spend hundreds of millions of years just flirting with each other. Long-distance gravitational attraction begins when they're still millions of light-years apart. They circle each other like cosmic dancers learning the steps. Only then do they commit to the final embrace. Individual stars race around galactic centers at hundreds of kilometers per second. They complete their orbits in mere hundreds of millions of years. But gravitational dances between entire galaxies operate on timescales comparable to stellar evolution itself. The universe deliberately calibrated these cosmic collisions to unfold slowly. It is slow enough for countless generations of stars to live entire lifetimes during a single galactic merger. Step on a bathroom scale. You're measuring Earth's gravitational grip on your body. Our entire planet barely registers compared to the gravitational monsters engaged in cosmic wrestling matches across the universe. When two massive galaxies lock into gravitational combat, they're throwing around masses that make our solar system look like cosmic dust. Our Milky Way weighs roughly 1 trillion times more than our Sun. That's a 1 followed by 12 zeros worth of stellar material. Imagine trying to visualize that much mass concentrated into a single cosmic structure. Every grain of sand on every beach on Earth wouldn't even approach the number of stars contained within our galactic neighborhood. Andromeda galaxy outweighs us by at least 2 to 1, possibly 3 to 1. These cosmic heavyweight champions are preparing for the ultimate gravitational wrestling match. When they finally lock together in 4.5 billion years, something extraordinary happens. The collision will release energy equivalent to thousands of supernovae exploding simultaneously across millions of years. The gravitational forces involved defy comprehension. Long before physical contact, each galaxy begins reshaping its opponent through pure gravitational pressure. Computer models show how spiral arms stretch and distort millions of years before collision. Stars get flung into intergalactic space like cosmic confetti. New stellar highways form as gravitational traffic patterns completely reorganize. Yet somehow this represents a gentle process by cosmic standards. The collision energy gets distributed across such vast timescales and distances that individual stellar neighborhoods barely notice the chaos. It's like renovating a city by moving one building per decade, dramatic from above, barely perceptible to individual residents. Most remarkably, these gravitational titan battles happen everywhere throughout the universe. The Hubble Space Telescope captures cosmic wrestling matches in every direction we look. Galaxies merging in elegant spirals, others locked in chaotic multi-way collisions involving 3 or 4 participants. Ever watched a controlled building demolition? explosives carefully placed to bring down a massive structure without damaging surrounding buildings. Galactic collisions work exactly like that, except they're demolishing and rebuilding entire cosmic neighborhoods while preserving virtually every individual resident. Watch what happens when spiral galaxies merge. Those elegant rotating arms that took billions of years to form get completely destroyed within a few 100 million years of collision. The organized traffic patterns that guided stars in neat orbital highways dissolve into gravitational chaos. Yet this apparent destruction actually represents sophisticated cosmic construction. The collision creates something entirely new, a massive elliptical galaxy that dwarfs both original participants. These cosmic metropolitans house trillions of stars in sprawling three-dimensional neighborhoods. They extend for hundreds of thousands of light years. The new residents enjoy much more spacious accommodations compared to their previous cramped spiral apartments. This architectural transformation follows surprisingly predictable patterns. Small galaxies always get absorbed by larger neighbors. Medium-sized galaxies merge into elliptical megacities. The most massive galaxies become cosmic empires that dominate entire regions of space. Each collision follows the universe's zoning regulations perfectly. The cosmic architects operate with remarkable precision despite the apparent chaos. Computer simulations show how gravitational forces sculpt new, stellar neighborhoods with mathematical elegance. Material flows from the outer regions toward the center. Dense stellar clusters form at specific distances from the galactic core. Everything settles into new orbital patterns that will remain stable for billions of years. Most impressively, these cosmic construction projects never stop. Right now throughout the universe, thousands of galactic collisions are reshaping stellar neighborhoods. Each one creates architectural masterpieces that surpass anything human city planners could imagine. The universe constantly renovates itself through controlled demolition. It manages to save every valuable piece while creating something entirely new. Circle December 25th on your calendar. Now imagine circling a date that's 4.5 billion years in the future. That's when our Milky Way keeps its appointment with Andromeda galaxy for the most spectacular collision our solar system will ever witness. This isn't a possibility or a probability. It's a guaranteed cosmic appointment that's been scheduled since these galaxies first formed billions of years ago. Andromeda approaches us right now at 110 kilometers per second. Every year it gets 3.5 billion kilometers closer. That might sound fast until you realize it still needs to cross 2.5 million light years of space before arrival. Even cosmic express trains require patience when traveling such astronomical distances. When collision day finally arrives, our night sky will transform beyond recognition. Andromeda will gradually grow from a faint smudge into a massive spiral structure dominating half the visible sky. For the first time in human history, people will be able to see individual star clusters in another galaxy with the naked eye. The collision will create the greatest light show in Earth's 4.6 billion year history. Aurora displays will pale in comparison. Meteor showers will seem like cosmic opening acts. Even total solar eclipses will appear modest compared to having an entire galaxy sprawled across half the visible sky. Our solar system will almost certainly survive this cosmic catastrophe. Computer models show a 75% chance we'll get ejected from the galactic core to a more remote location. We might end up 50,000 light years farther, from the new galactic center. Earth will probably remain safely locked in orbit around our Sun throughout the entire billion-year merger process. The collision will birth something astronomers are already calling Milky Way, a massive elliptical galaxy containing the combined stellar populations of both participants. This cosmic metropolis will house over 600 billion stars spread across 200,000 light-years. Every constellation we've ever named will disappear. Every star pattern that guided ancient navigation will be completely rearranged. Yet somehow this represents just another day at the office for cosmic architects. Your kitchen contains a refrigerator, a coffee maker, and a fruit bowl. Every object you can see represents the kind of matter that makes up stars, planets, and people. Now imagine that 85% of your kitchen consists of completely invisible furniture. You can't see it, touch it, or detect it, but this invisible stuff controls where everything else sits and how it moves around the room. Welcome to the cosmic reality that broke astronomy. Scientists first weighed entire galaxies in the 1970s. The numbers made absolutely no sense. Galaxies contained roughly 5 times more gravitational influence than all their visible stars could possibly account for. Something massive was hiding in plain sight throughout the entire universe. This invisible cosmic scaffold goes by the name dark matter. Nobody knows what it's actually made of. It doesn't emit light. It doesn't absorb light. It does not seem to interact with regular matter in any way except through gravity. Yet this mystery substance forms the true backbone of every galaxy collision happening throughout the cosmos. Dark matter creates invisible frameworks that extend far beyond the visible edges of galaxies. These ghostly halos stretch 3 times farther than the stars we can actually see. When galaxies approach each other, their dark matter halos make first contact millions of years before their visible stars even know anything is happening. Think of it like cosmic puppet theater. All the spectacular stellar fireworks we observe during galaxy collisions represent just the visible performance. Behind the cosmic curtain, invisible dark matter halos serve as the real choreographers. They determine when galaxies will collide. They control how galaxies approach each other. They dictate what the final merged structure will look like. Without dark matter's invisible influence, galaxy collisions would be much rarer. The visible stars alone lack sufficient gravitational muscle to capture other galaxies across such enormous distances. Long-distance relationships challenge even the most committed couples. Imagine maintaining gravitational attraction across 2.5 million light-years of empty space. That's the cosmic love story currently unfolding between our Milky Way and Andromeda galaxy. These stellar metropolises have been gravitationally flirting with each other since before complex life existed on Earth. Gravity represents the universe's most patient matchmaker. Unlike electromagnetic forces that weaken rapidly with distance, gravitational attraction never truly disappears. It just gets extremely subtle. 2 galaxies separated by millions of light-years still feel each other's gravitational pull. The force might be incredibly weak. It is billions of times weaker than the gravity holding you to your chair right now. But it never stops working. Andromeda outweighs our Milky Way by at least 2 to 1, possibly 3 to 1. In the cosmic dating game, mass equals attraction power. The bigger galaxy naturally wins any gravitational tug-of-war. Our galactic neighborhood finds itself slowly but inevitably drawn toward this cosmic heavyweight. like a moth to a stellar flame. This gravitational courtship operates on timescales that dwarf human comprehension. The attraction began when these galaxies first formed billions of years ago. They've been gradually spiraling toward each other ever since. Every year, Andromeda moves 3.5 billion kilometers closer to its date with destiny. Computer simulations reveal the cosmic answer to what happens when irresistible gravitational force meets equally immovable galactic mass. The approaching galaxies won't collide head-on like cosmic billiard balls. Instead, they'll perform an elegant gravitational ballet. They'll circle each other multiple times before finally settling into gravitational matrimony. Modern astronomy can predict this cosmic wedding with remarkable precision. We know the approximate date. We understand the gravitational mechanics. We can even preview the stellar rearrangements that will result. Picture two cosmic forces locked in the ultimate arm wrestling match. In one corner sits universal expansion, constantly stretching space itself and carrying galaxies away from each other at ever-increasing speeds. In the other corner stands gravity, working tirelessly to pull everything back together. These opposing cosmic forces wage war throughout the universe. They determine which galaxies get to collide and which ones drift apart forever. Universal expansion operates like a cosmic conveyor belt that never stops moving. Every second, space itself stretches slightly. This adds new emptiness between distant objects. The process happens everywhere simultaneously. The farther apart two objects sit, the faster they separate due to expanding space. Objects located far enough apart eventually move away faster than light itself could travel between them. Yet gravity refuses to surrender without a fight. Within smaller cosmic neighborhoods, gravitational attraction can actually overpower universal expansion. Our local group contains the Milky Way, Andromeda, and dozens of smaller galaxies. It represents one such gravitational victory zone. Here, mutual attraction proves stronger than the expanding space trying to separate galactic neighbors. The cosmic scoreboard currently favors expansion by a wide margin. Most galaxies throughout the universe are already separating too rapidly for gravity to ever reunite them. We live during a special cosmic epoch when some galaxies remain close enough for gravitational marriage. In another 100 billion years, expanding space will have stretched the universe so much that galaxy collisions become virtually impossible. This creates cosmic irony on the grandest scale. Right now represents peak galaxy collision season in the universe's long-term weather forecast. We're witnessing the last great era of galactic mergers. Future civilizations will inhabit a much lonelier cosmos. Individual galaxies will sit isolated in expanding darkness, forever separated by distances too vast for gravity to bridge. Our upcoming collision with Andromeda represents one of the universe's final cosmic construction projects. Someone sneezes in Beijing, and a butterfly flaps its wings in Brazil. Neither event seems capable of reshaping continents. About 13.8 billion years ago, space contained an almost perfectly smooth matter distribution. Almost perfectly. Tiny density variations, differences of just 1 part in 100,000, created barely detectable ripples in the cosmic fabric. These microscopic irregularities would eventually grow into the galaxy-smashing titans that dominate cosmic architecture today. The early universe operated like the world's most sensitive amplification system. Those infinitesimal density variations provided gravitational seeds for everything that followed. Regions with slightly more matter attracted slightly more material from their surroundings. This gradual accumulation process operated with relentless patience across cosmic time. Gravity transformed whisper-quiet irregularities into cosmic thunderstorms spanning billions of years. Dense regions kept getting denser. Empty regions became increasingly empty. The universe organized itself into a vast cosmic web. Matter-rich filaments became separated by enormous voids. Galaxy collisions represent the inevitable result of this cosmic urban planning process. Computer simulations reveal this cosmic butterfly effect in stunning detail. Start with the actual density variations detected in the cosmic microwave background radiation. Let gravity operate for 13.8 billion years following known physics. The simulation produces a universe that looks remarkably similar to what telescopes actually observe, complete with galaxy clusters, collision zones, and vast empty regions. Those ancient density ripples determined which galaxies would eventually collide billions of years later. Our collision with Andromeda was essentially predetermined when the universe was less than 400,000 years old. The cosmic dice were cast long before the first stars ignited. We're simply following a gravitational script that was written in the earliest moments of cosmic history. Rush hour traffic involves maybe 1,000 cars trying to navigate a few dozen intersections. Now imagine 1,000 entire galaxies attempting to coordinate their gravitational movements within the same cosmic neighborhood. Welcome to the Virgo cluster. It is the universe's most spectacular traffic jam. Gravitational chaos reigns supreme. Collision accidents happen constantly. This cosmic metropolitan area spans 15 million light-years from edge to edge. It contains roughly 1,300 member galaxies. Each follows its own gravitational flight path through space. Giant elliptical galaxies cruise through like cosmic 18-wheelers. Smaller spiral galaxies dart between larger neighbors like cosmic sports cars. Dwarf galaxies get pushed around like cosmic motorcycles trying to avoid getting squashed. At the center sits the cosmic equivalent of a traffic cop gone rogue. A supergent elliptical galaxy called M87 has been systematically consuming smaller neighbors for billions of years. It contains 6 trillion stars. It hosts a central black hole that outweighs our Sun by 6.5 billion to 1. M87 dominates local traffic patterns through pure gravitational intimidation. The gravitational interactions within this cosmic traffic jam defy simple description. Multiple galaxies experience simultaneous gravitational influences from dozens of different neighbors. Computer simulations reveal chaotic orbital patterns that make Earth's weather prediction look straightforward. Small gravitational nudges can completely alter galactic trajectories millions of years later. Unlike earthly traffic jams that resolve within hours, this cosmic version has been ongoing for billions of years. Galaxies continue merging, separating, and rearranging themselves according to gravitational rules too complex for complete understanding. Each collision creates ripple effects that influence neighboring galaxies across millions of light years. The Virgo cluster operates like a cosmic engine for producing galaxy collisions through pure gravitational chaos. Every great love story starts with that first meaningful glance across a crowded room. In the cosmic version, that crowded room spans 2.5 million light years. The first meaningful glance takes 500 million years to complete. When two galaxies begin their gravitational courtship, They're operating on a romantic timeline that makes human relationships look like speed dating. The cosmic romance begins with subtle gravitational flirtation across impossible distances, long before either galaxy shows visible signs of disturbance. Their dark matter halos start the slow dance of mutual attraction. Think of it like cosmic pheromones, invisible signals that travel at the speed of gravity. These signals gradually strengthen as the distance shrinks. Computer simulations reveal this opening act in stunning detail. The approaching galaxies spend their first few 100 million years simply getting acquainted through long-range gravitational messaging. No dramatic stellar fireworks yet. No obvious structural changes. Just two massive cosmic entities slowly adjusting their orbital trajectories like cosmic cruise ships making gentle course corrections. During this extended courtship phase, both galaxies continue their normal stellar business. Stars are born. Stars die in spectacular supernova. Planetary systems form around newly minted suns. Entire civilizations could rise and fall multiple times while their host galaxies engage in this patient gravitational foreplay. The cosmic romance operates on timescales that dwarf any individual stellar lifetime. Yet even from these astronomical distances, destiny becomes increasingly inevitable. Each passing million years brings the galaxies slightly closer together. Their gravitational embrace grows progressively stronger. What started as barely detectable cosmic attraction evolves into undeniable gravitational destiny. By the end of Act 1, both galaxies have committed to their cosmic collision course. There's no possibility of changing their minds. The universe deliberately calibrated galactic courtship for maximum dramatic tension. The approaching galaxies can sense each other's presence across millions of light years. Yet they must wait hundreds of millions of years before their first intimate contact. Maximum anticipation, minimum instant gratification. The cosmic romance enters its first dramatic phase when galaxies reach tidal influence distance. Suddenly, the gentle long-range flirtation transforms into something far more intimate and destructive. The outer regions of both galaxies begin experiencing gravitational forces that their stellar residents have never encountered before. Tidal forces operate like cosmic taffy pullers. Earth's gravity creates ocean tides by pulling slightly harder on water closest to our planet. Approaching galaxies create stellar tides by pulling unevenly on different galactic neighborhoods. Stars orbiting the outer edges of each galaxy suddenly find themselves caught between competing gravitational loyalties. Should they remain faithful to their home galaxy, or surrender to the seductive pull of their cosmic suitor? The first casualties of this gravitational love triangle are the galactic suburbs. Stars that spent billions of years in peaceful outer orbits get stretched into long stellar streams. These streams trail behind each galaxy like cosmic hair flowing in gravitational wind. Stellar refugees form spectacular tidal tails that can extend for hundreds of thousands of light years into intergalactic space. Hubble Space Telescope images capture this cosmic soap opera in gorgeous detail. The famous Mice galaxies display dramatic tidal tails stretching in opposite directions like cosmic whiskers. The antenna galaxies show off massive stellar streams that extend farther than the original galaxies themselves. Each image represents a cosmic romance caught in the act of gravitational passion. Most of the stellar residents getting flung into intergalactic exile will never return home. They become cosmic expatriates, doomed to wander the empty space between galaxies for the rest of cosmic time. These stellar refugees pay the price for their galaxy's gravitational romance. They sacrifice their cosmic neighborhoods for their home galaxy's greater gravitational passion. Yet somehow this represents gentle treatment by cosmic standards. The galaxies are still millions of light years apart during this phase. The real gravitational passion hasn't even begun yet. The cosmic romance reaches its first dramatic climax when the two galaxies finally make their closest approach. After hundreds of millions of years of gravitational foreplay, the stellar lovers execute a cosmic near-miss. It sends gravitational shock waves throughout both galactic neighborhoods. The universe's ultimate example of stellar passion without actual physical contact. During this first close encounter, the galaxies sweep past each other at hundreds of kilometers per second. Their gravitational fields interact like invisible hands. They grab and fling stellar neighborhoods in directions that defy galactic traffic laws. Billions of stars that spent their entire lives following predictable orbital patterns suddenly find themselves launched onto completely new cosmic trajectories. The gravitational chaos creates cosmic pinball effects throughout both galaxies. Stars get gravitationally deflected by the competing influences of their home galaxy and their cosmic visitor. Some get accelerated to escape velocity and flee into intergalactic space like cosmic refugees seeking asylum. Others get decelerated and fall toward their galaxy's center in dramatic stellar migrations spanning millions of light years. Computer simulations reveal this cosmic drama in spectacular detail. The first close approach redistributes roughly 10% of each galaxy's stellar population. That represents tens of billions of individual star systems getting new cosmic addresses during a single gravitational encounter. It's like a cosmic real estate market where gravity serves as the ultimate landlord. Properties get reassigned according to purely gravitational economics. Most remarkably, this cosmic near-miss fails to satisfy either galaxy's gravitational appetite. Instead of continuing their separate ways after this intimate encounter, both galaxies find themselves gravitationally bound in an elliptical cosmic dance. Their first romantic encounter only increases their mutual gravitational attraction. This ensures they'll return for an even more passionate second meeting. The stellar casualties from this first cosmic encounter become permanent intergalactic wanderers. These stellar refugees will spend the rest of cosmic time traveling through the empty space between galaxy clusters. Forever separated from organized galactic society. Cosmic romance rarely achieves satisfaction on the first date. After their initial gravitational encounter, both galaxies discover they can't escape each other's gravitational embrace. What follows is a cosmic return engagement that makes their first meeting look like a gentle handshake. The second collision represents the universe's ultimate example of gravitational passion intensified by experience. The galaxies spend roughly 500 million years separating after their first encounter. Then gravitational attraction inevitably draws them back together. During this cosmic intermission, both stellar societies attempt to recover from their first gravitational trauma. New stellar neighborhoods form from the cosmic wreckage. Surviving star formation regions resume their business of creating baby suns. Yet destiny refuses to be delayed indefinitely. Gravitational mathematics ensures that what separates must eventually reconverge with even greater passion. The second approach follows a tighter orbital trajectory. It brings the galactic lovers closer together than their first shy encounter ever attempted. This time they mean serious gravitational business. The second collision makes their first meeting look like amateur cosmic theater. Gravitational forces that seemed intense during their initial approach now amplify to levels that completely reshape both galactic architectures. Spiral arms that survived the first encounter get totally destroyed during the second pass. Stellar orbits that manage to remain stable through one gravitational crisis finally surrender to cosmic chaos. This second cosmic embrace triggers massive bursts of star formation. Interstellar gas clouds get compressed by gravitational shock waves. The collision ignites cosmic fireworks, displays visible across intergalactic distances. Both galaxies experience stellar baby booms that produce newborn stars at rates hundreds of times faster than their normal cosmic reproduction cycles. Most importantly, the second collision removes any remaining possibility of gravitational escape. Both galaxies have now committed fully to cosmic marriage. Their mutual orbital energy has been dissipated through gravitational friction. They're gravitationally wed for better or worse, until heat death do them part. The cosmic romance concludes with the universe's most spectacular wedding ceremony. A billion-year celebration forms two distinct galactic personalities into a single, massive cosmic entity. This represents gravitational marriage at its most profound level. Individual identities merge completely into something entirely new and unprecedented. The final merger resembles cosmic alchemy more than simple galactic addition. Two spiral galaxies with elegant rotating arms and organized stellar traffic patterns disappear forever. In their place emerges a massive elliptical galaxy, a sprawling three-dimensional stellar metropolis. It dwarfs both original participants. The cosmic newlyweds have created galactic offspring that inherits characteristics from both parents. Yet it develops entirely unique personality traits. This cosmic wedding reception lasts roughly 100 million years. It features the universe's most spectacular fireworks display. The final gravitational merger triggers the last great burst of star formation. Remaining gas clouds get compressed beyond their ability to resist gravitational collapse. Millions of new stellar neighborhoods ignite simultaneously across the merged galaxy. A cosmic baby boom celebrates the successful completion of gravitational matrimony. The cosmic wedding also features a dramatic black hole merger. The central supermassive black holes from both original galaxies finally meet after billions of years of cosmic courtship. These gravitational monsters spiral toward each other in a dance that generates ripples in space-time itself. When they finally merge, the cosmic wedding bells ring throughout the universe. They create gravitational waves detectable by sensitive instruments across intergalactic distances. What emerges from this cosmic union represents an entirely new galactic species. The merged elliptical galaxy contains the combined stellar populations of both original participants. Typically 500 billion to 1 trillion stars spread across 200,000 light-years of space. This cosmic metropolis will remain gravitationally stable for hundreds of billions of years. It serves as a monument to the power of gravitational romance. Most remarkably, computer simulations show that virtually every individual star survives this billion-year cosmic wedding ceremony. Despite the apparent violence and chaos of galactic collision, the actual stellar casualty rate remains incredibly low. The cosmos manages to completely transform galactic architecture while preserving almost every individual stellar resident. A typical maternity hospital delivers maybe 20 babies per day. Imagine that same hospital suddenly delivering 2,000 babies every single day for the next 100 years. Now scale that demographic explosion across entire galactic neighborhoods containing billions of potential stellar nurseries. When galaxies collide, they trigger the universe's most spectacular baby booms. Stellar reproduction frenzies transform sleepy cosmic suburbs into blazing stellar maternity wards. Under normal galactic conditions, star formation proceeds at a leisurely pace. Our Milky Way produces roughly 2 new stars per year from the slow gravitational collapse of cold gas clouds. This cosmic reproduction rate has remained fairly steady for billions of years. Star formation represents one of the universe's most patient construction projects. Individual stellar pregnancies last millions of years from conception to birth. Galaxy collisions completely shatter this cosmic reproductive schedule. Gravitational shock waves from the collision compress interstellar gas clouds far beyond their normal density thresholds. What previously required millions of years of gradual gravitational squeeze now happens in mere hundreds of thousands of years. The collision essentially induces cosmic labor in gas clouds that weren't ready for stellar parenthood. The resulting stellar baby boom defies astronomical expectations. Colliding galaxies can produce new stars at rates 100 to 1,000 times faster than their pre-collision baseline. These cosmic population explosions earn the astronomical term starburst galaxies. Stellar reproduction becomes so intense it becomes visible across intergalactic distances. The newborn stars blaze so brightly they outshine entire normal galaxies. Astronomers can observe these cosmic maternity wards throughout the universe using infrared telescopes. These instruments detect heat from stellar nurseries. The most dramatic examples produce thousands of new stars per year instead of the typical handful. Some starburst galaxies burn through their entire gas supply so rapidly they exhaust their capacity for future star formation within just 100 million years. The collision-induced star formation often creates stellar neighborhoods unlike anything possible under normal galactic conditions. Dense stellar clusters containing millions of newborn stars get packed into regions smaller than our solar neighborhood. These cosmic daycare centers house so many brilliant young stars that radiation pressure eventually disperses the remaining gas. The stellar reproduction factory shuts down almost as rapidly as it started. Every galaxy collision features a wedding ceremony so spectacular it shakes the very fabric of space-time itself. At the heart of each colliding galaxy lurks a supermassive black hole, gravitational monsters millions of times more massive than our Sun. When galaxies merge, these cosmic titans must eventually consummate their own gravitational marriage, the universe's most energetic celebration. The black hole courtship begins millions of years before the actual merger. As their host galaxies spiral together, the central black holes start their own cosmic dance within the merged galactic core. Initially separated by thousands of light years, they slowly spiral inward. They eject stellar bystanders through gravitational slingshot effects. This cosmic wedding preparation takes roughly 100 million years to complete. The final black hole merger represents perhaps the most violent event possible in the universe. When two supermassive black holes finally touch, They don't simply add their masses together like cosmic arithmetic. Instead, they create gravitational chaos so intense it warps space-time itself into ripples. These ripples propagate across the universe at light speed. These gravitational waves can carry energy equivalent to about 40 trillion years of our Sun's total output, all released in just a few minutes. Advanced gravitational wave detectors can now eavesdrop on some of these cosmic wedding ceremonies from billions of light years away. The LIGO and Virgo observatories have recorded dozens of mergers of smaller black holes. Each one produces a distinctive gravitational chirp as the spiral accelerates toward its inevitable conclusion. Cosmic wedding bells ringing throughout the universe, audible only to our most sensitive gravitational instruments. The merged black hole that emerges from this cosmic matrimony typically weighs slightly less than the sum of its parents. The missing mass gets converted directly into gravitational wave energy according to Einstein's famous equation. Roughly 3 solar masses worth of pure matter transforms into space-time ripples during a typical black hole merger, the universe's most efficient energy conversion process. Most remarkably, these cosmic wedding ceremonies happen regularly throughout the universe. Astronomers estimate that major black hole mergers occur roughly once per day somewhere in the observable cosmos. Each event represents the gravitational finale to a billion-year galactic collision story. Galaxy collisions perform the universe's most dramatic makeovers. Cosmic beauty treatments completely transform galactic hairstyles from elegant spiral curls into bland, featureless cosmic crew cuts. What takes billions of years to grow gets restyled in just a few 100 million years of gravitational chaos. The results represent some of astronomy's most controversial before and after transformations. Spiral galaxies represent the universe's most photogenic galactic architecture. Those graceful rotating arms that sweep outward from galactic centers take billions of years to develop their mature elegance. The spiral pattern emerges from delicate gravitational choreography. Density waves organize stellar traffic into beautiful curved highways. These cosmic masterpieces require precisely balanced conditions to maintain their structural integrity. Galaxy collisions completely destroy this delicate spiral architecture. The gravitational chaos scrambles the organized rotation that maintains spiral arm patterns. Stellar orbits that previously followed predictable circular paths around the galactic center get scattered into random 3-dimensional trajectories. The elegant flat disk structure that defines spiral galaxies puffs up into a bloated spherical arrangement. What emerges from this cosmic makeover represents galactic architecture's equivalent of geometric minimalism. Elliptical galaxies display smooth, featureless light profiles that increase gradually toward their centers. No spiral arms, no organized rotation, no distinctive structural elements that distinguish one elliptical galaxy from another. They're essentially cosmic geometric forms, stellar populations arranged in 3-dimensional football shapes. This transformation represents more than just cosmetic galactic surgery. Elliptical galaxies typically contain much older stellar populations than their spiral predecessors. The collision-induced starburst consumes most available gas for star formation. This leaves behind mature stellar neighborhoods with little capacity for cosmic reproduction. These post-collision galaxies become cosmic retirement communities populated mainly by elderly stars. Yet somehow this cosmic makeover produces some of the universe's most impressive galactic cities. Giant elliptical galaxies can contain trillions of stars spread across hundreds of thousands of light years. They're the cosmic equivalent of Los Angeles, sprawling suburban developments that house enormous stellar populations in relatively bland but efficient architectural layouts. Galaxy collisions create the universe's most spectacular interior decorating projects. Cosmic ribbon-cutting ceremonies stretch stellar streamers across hundreds of thousands of light-years of previously empty space. These gravitational sculpture installations represent some of the most beautiful and ephemeral art the cosmos ever produces. The stellar ribbons form through purely gravitational artistry. As galaxies approach each other, tidal forces stretch their outer regions into long trails of stars. These trails flow away from the collision zone like cosmic hair blowing in gravitational wind. These tidal tails contain millions of individual stars that get pulled away from their galactic homes. They scatter across intergalactic distances. Some cosmic ribbon installations achieve truly spectacular dimensions. The famous Mice galaxies trail stellar streamers that extend over 300,000 light-years from their galactic centers. That's longer than the original galaxies themselves. The tadpole galaxy shows off a single enormous tail containing billions of stars. It stretches across 280,000 light-years of space. These represent cosmic sculpture on scales that dwarf anything possible in terrestrial art. The gravitational sculpting process operates with mathematical precision despite the apparent chaos. Computer simulations can predict exactly which stellar neighborhoods will get stretched into tidal tails. They can predict which directions those cosmic streamers will flow. The final ribbon patterns depend entirely on the collision geometry, approach speeds, and mass ratios of the participating galaxies. Most of these cosmic decorations represent temporary cosmic art installations. They gradually fade over hundreds of millions of years. The scattered stars in tidal tails typically lack sufficient gravitational binding to maintain their streamer formations. They slowly disperse into intergalactic space, leaving behind only faint traces of their former cosmic beauty. Meanwhile, some stellar refugees from these cosmic ribbon-cutting ceremonies eventually get recycled into new galactic architecture. The gravitational chaos can scatter tidal tail material across such vast distances that it gets captured by entirely different galaxy groups. These cosmic immigrants contribute their stellar heritage to foreign galactic neighborhoods. They create cosmic cultural exchange programs spanning millions of light years. Galaxy collisions function like the universe's most ambitious genetic engineering laboratories. Cosmic breeding programs mix stellar DNA for completely different galactic species. They create hybrid offspring that inherit characteristics from both parents while developing entirely unprecedented traits. These cosmic crossbreeding experiments produce galactic children unlike anything the universe had previously attempted. Each galaxy brings its own distinctive stellar genetics to the cosmic mating process. Spiral galaxies contribute young, energetic star populations along with abundant gas supplies for future stellar reproduction. Elliptical galaxies offer mature stellar neighborhoods and massive central black holes. These develop through billions of years of gravitational evolution. The collision mixes these stellar bloodlines in ways impossible through normal galactic development. The hybrid galactic offspring display fascinating combinations of parental characteristics. Some merger remnants contain both old, elliptical-type stellar populations in their centers and younger spiral-type stars scattered throughout their outer regions. Others develop entirely new structural features that don't match any pre-collision galactic classification schemes. These cosmic mutants challenge astronomers' traditional galaxy taxonomy systems. Most remarkably, some cosmic breeding programs produce galactic species that seem impossible according to standard galaxy formation theories. Ultra-compact dwarf galaxies pack stellar densities comparable to globular clusters into structures hundreds of times larger. These cosmic anomalies likely represent the stripped cores of larger galaxies that survived violent collision encounters. They're essentially galactic fossils that preserve evidence of ancient cosmic genetic engineering experiments. The universe's cosmic breeding program operates on industrial scales throughout cosmic history. Astronomers estimate that most large galaxies have experienced at least one major merger during their lifetimes. Our own Milky Way bears genetic scars from multiple cosmic crossbreeding events. This includes ongoing digestion of the Sagittarius dwarf galaxy. We're living inside a cosmic hybrid that continues evolving through gravitational genetic engineering. Future cosmic breeding programs will create even more exotic galactic species as the universe ages. Computer simulations predict that our upcoming merger with Andromeda will produce a hybrid elliptical galaxy. It will contain stellar populations from both spiral parents. This Milky Way galaxy will represent the latest addition to the universe's growing collection of cosmic genetic engineering success stories. Andromeda galaxy has been traveling toward our cosmic neighborhood for over 4 billion years. It moves with the persistence of the universe's most determined party crasher. Right now, as you read this sentence, our galactic neighbor barrels toward us at a wonder 10 kilometers per second. That's fast enough to cross the continental United States in 90 minutes. This cosmic freight train maintains perfect aim despite crossing distances that boggle human comprehension. Every single day, Andromeda moves 9.5 million kilometers closer to our galactic doorstep. That's roughly 25 times the distance from Earth to the Moon added to our cosmic collision countdown every 24 hours. Yet this relentless approach requires such astronomical patience that Andromeda won't arrive for another 4.5 billion years. It's like watching continental drift happen at highway speeds. Astronomers can track this cosmic stalker with remarkable precision using the Doppler effect. An approaching ambulance siren sounds higher in pitch. Approaching galaxies show their light shifted toward the blue end of the spectrum. Andromeda's light carries the unmistakable signature of something massive moving directly toward us at tremendous speed. There's absolutely no ambiguity about its current motion. The cosmic mathematics make this appointment feel inevitable. Some estimates put Andromeda ahead of the Milky Way in mass. The exact margin is uncertain. In any gravitational wrestling match, the heavier galaxy tends to win. We're essentially a cosmic lightweight getting pulled toward a gravitational heavyweight. This heavyweight has been training for this bout since the universe was young. There's literally nothing we can do to avoid this appointment. No cosmic course corrections. No gravitational evasive maneuvers. No intergalactic restraining orders. The laws of physics have put this encounter on a long cosmic schedule. Gravity itself steers both galaxies toward a future interaction. Meanwhile, universal expansion works desperately to separate us from this cosmic fate. Every second, the space between galaxies stretches slightly. It tries to pull Andromeda away from its collision course. But gravity laughs at these feeble expansion efforts. Within our local group of galaxies, gravitational attraction overpowers cosmic expansion by enormous margins. Our rendezvous with destiny remains a strong possibility. Prepare for the ultimate cosmic IMAX experience, expected to begin roughly 1 billion years before any close encounter. As Andromeda approaches our galactic neighborhood, it will gradually transform from an invisible smudge. It will become the most spectacular celestial object ever visible from Earth's surface. Future sky watchers will witness galactic architecture with naked eye detail that makes today's astronomy textbooks look like cosmic thumbnails. Currently, Andromeda appears as a faint fuzzy patch barely visible without binoculars. This remains true even under perfect dark skies. Most people live their entire lives without ever noticing this cosmic neighbor. That cosmic invisibility will change dramatically as gravitational destiny unfolds. Andromeda will grow progressively brighter and larger until it dominates the night sky, like a cosmic cathedral spanning horizon to horizon. The visual transformation will unfold with geological patience but astronomical drama. Computer simulations reveal how our cosmic neighbor will gradually resolve into individual spiral arms visible to the naked eye. Future humans will be able to see star-forming regions in another galaxy without any optical assistance. Dark dust lanes threading through Andromeda's spiral structure will become as obvious as the Milky Way's current appearance. At maximum approach, Andromeda will appear roughly 6 times larger than the full moon. This despite being millions of times farther away. The galaxy's central bulge alone will span several moon diameters across the sky. Those elegant spiral arms will stretch across 30 degrees of sky. That's equivalent to 60 full moons placed side by side. It will become impossible to see the entire galaxy in a single glance. This cosmic spectacle will create the most dramatic sky show in Earth's 4.6 billion year history. Aurora displays will pale in comparison. Meteor showers will seem like cosmic opening acts. Even total solar eclipses will appear modest compared to having an entire galaxy sprawled across half the visible sky. The approach will also trigger spectacular gravitational fireworks as both galaxies begin their cosmic dance. Massive star formation bursts will ignite across both galactic disks. They'll create brilliant stellar neighborhoods visible across intergalactic distances. The collision could light up the night sky with newborn stars blazing at intensities far exceeding anything Earth's sky has ever displayed. Pack your bags for the ultimate cosmic relocation program. Computer simulations suggest a roughly 75% probability that our solar system will get evicted from its current galactic address. We'll be relocated to the cosmic equivalent of suburban exile. The gravitational chaos of galaxy collision operates like the universe's most dramatic real estate market. Gravity serves as the ultimate landlord, reassigning cosmic properties. Our solar system currently enjoys prime galactic real estate roughly 26,000 light-years from the Milky Way's center. This cosmic suburb provides perfect conditions for planetary habitability. We're close enough to benefit from heavy elements created by previous stellar generations, yet we're far enough from the galactic core to avoid deadly radiation and gravitational chaos. we've been living in the galactic equivalent of a gated community for billions of years. Galaxy collision will likely terminate our cosmic lease on this premium location. Gravitational interactions during the merger will fling our solar system outward. We'll be relocated to a new address roughly 75,000 light-years from the merged galaxy's center. That represents cosmic gentrification in reverse. We're getting relocated from downtown galactic suburbia to the stellar equivalent of rural farmland. This cosmic moving day won't happen suddenly. The relocation process will unfold gradually across hundreds of millions of years as gravitational forces slowly alter our solar system's orbital trajectory. Earth will remain safely locked in orbit around our Sun throughout this cosmic address change. The planets will continue their predictable dance around our stellar furnace, while the entire solar system gets gravitationally relocated to its new galactic neighborhood. The relocation actually improves our solar system's long-term survival prospects. Our new galactic address will be much safer than remaining near the chaotic merger zone. Stars that avoid ejection from the collision often get scattered into unstable orbits. These eventually lead them too close to the new galaxy's supermassive central black hole. Meanwhile, roughly 25% of the original stellar residents will experience even more dramatic cosmic relocations. Computer models show that significant stellar populations get completely ejected from the merged galaxy during the collision chaos. These cosmic refugees become permanent intergalactic wanderers, forever separated from organized galactic society, doomed to drift through empty space between galaxy clusters. Every constellation that has ever guided human navigation will disappear forever. The Big Dipper, Orion the Hunter, the Southern Cross, Cassiopeia. All 88 officially recognized star patterns that have decorated Earth's sky for millions of years will be completely erased. They'll be replaced with entirely new stellar arrangements that no human civilization has ever imagined. The cosmic interior redesign begins long before actual galaxy collision. Gravitational tidal forces will start rearranging stellar neighborhoods roughly 500 million years before final merger. Stars that have maintained the same relative positions for hundreds of millions of years will begin drifting into completely new configurations. Ancient star patterns will gradually distort beyond recognition. This represents the most dramatic cosmic redecorating project in Earth's history. The familiar stellar landmarks that have oriented human cultures since civilization began will slowly morph into alien arrangements. Polaris will no longer point north. The zodiac constellations will bear no resemblance to their current patterns. Navigation by stars will require completely new stellar maps drawn from scratch. Computer simulations reveal the scope of this cosmic renovation project. Roughly 90% of the stars currently visible from Earth will end up in completely different sky positions after the galactic merger completes. The remaining 10% will maintain approximately similar locations, but their neighbors will change so dramatically that familiar star patterns become unrecognizable. The collision will also add entirely new stellar populations to Earth's sky. Stars that currently belong to Andromeda galaxy will join our cosmic neighborhood. They'll contribute their light to entirely novel constellation patterns. These cosmic immigrants will create hybrid stellar arrangements. They'll blend Milky Way natives with Andromeda refugees in ways impossible under normal galactic conditions. Future humans will inherit a completely alien night sky requiring brand new mythology. They'll need new navigation systems and cultural associations. Every star pattern that has inspired human art, religion, and exploration will exist only in historical records. The Cosmic Redecorating Project will force human civilization to develop entirely new relationships with the stellar arrangements overhead. Yet somehow this dramatic sky makeover preserves almost every individual star that contributes to current constellation patterns. The cosmic interior redesign achieves total stellar arrangement while maintaining nearly perfect preservation of individual stellar residents. The cosmic collision concludes with the universe's most ambitious urban planning project, the construction of Milky Way, a massive elliptical galaxy that will house the combined stellar populations of both former galactic neighbors. This cosmic metropolis will stretch 200,000 light-years from edge to edge. It will contain roughly 600 billion stellar residents living in entirely redesigned galactic architecture. The merged galaxy will dwarf both original participants in pure scale and grandeur. Milky Way will rank among the universe's largest elliptical galaxies. It'll be comparable to the cosmic megalopolises found at the centers of major galaxy clusters. This stellar empire will dominate the local group's gravitational landscape for hundreds of billions of years. It serves as the ultimate monument to successful galactic urban renewal. The architectural transformation will be nothing short of revolutionary. Both original spiral galaxies with their elegant rotating disk structures will disappear completely. In their place will emerge a three-dimensional stellar city where stars orbit in complex elliptical trajectories. These trajectories extend in all directions from the galactic center. The new cosmic metropolis will resemble a giant stellar football more than the flat cosmic carousel we currently call home. Milky Way's downtown region will become a bustling stellar business district. It'll contain the merged supermassive black holes from both original galaxies. This cosmic downtown will house roughly 100 billion stars within the central 50,000 light-years. That's a stellar density far exceeding either original galaxy's urban core. The gravitational architecture will create stable orbital neighborhoods capable of supporting stellar communities for hundreds of billions of years. The Cosmic Urban Planning Project will also feature extensive stellar suburbs spreading across the galaxy's outer regions. These residential stellar neighborhoods will house the majority of Milky Way's stellar population in stable, long-term orbital configurations. Most remarkably, computer simulations show that virtually every star from both original galaxies will receive new addresses in this cosmic metropolis. This happens without experiencing collision casualties. Perhaps most impressively, Milky Way will represent the local group's final major construction project. After this cosmic merger completes, universal expansion will have stretched intergalactic distances so far that no other large galaxies remain within gravitational range. The cosmic construction industry will essentially shut down. Milky Way becomes the permanent architectural legacy of our cosmic neighborhood's most ambitious urban renewal program. The new galactic metropolis will provide a stable cosmic home for any civilizations lucky enough to witness this ultimate cosmic construction project. Step into the universe's most whimsical art gallery. Galaxy collisions create cosmic creatures that would make any children's book illustrator jealous. The famous mice galaxies, and GC 4676 stretch their stellar tails across 300,000 light-years of space, like cosmic rodents frozen mid-scurry. These aren't random gravitational accidents. They're the universe's proof that even the most violent cosmic events can produce results that make astronomers chuckle. The cosmic menagerie extends far beyond simple mice. The tadpole galaxy displays a perfectly formed stellar tail that streams behind its main body like a cosmic sperm swimming through intergalactic space. Meanwhile, the porpoise galaxy appears to leap through cosmic waters with its distinctive curved profile and trailing stellar wake. Each cosmic creature represents a gravitational collision caught at precisely the right moment to create recognizable animal shapes. Their animal resemblances result from perfectly predictable physics rather than cosmic coincidence. Computer simulations can reproduce these exact stellar tail formations by feeding the correct initial conditions into gravitational calculations. The universe creates cosmic art through pure mathematical beauty rather than supernatural intervention. The stellar tails themselves represent some of the most spectacular cosmic engineering in the universe. These streams contain millions of individual stars stretched across distances that dwarf entire galactic diameters. Yet each stellar refugee maintains its original nuclear furnace while participating in these cosmic art installations. It's like creating massive sculptures using only live materials that continue functioning throughout the artistic process. Hubble Space Telescope images reveal the intricate details of these cosmic creatures with stunning clarity. Individual star-forming regions appear as bright knots along the stellar tails. Dark dust lanes thread through the cosmic appendages like cosmic veins. Some tail structures show multiple generations of stellar streams created by repeated gravitational encounters between the same galactic participants. Perhaps most remarkably, these cosmic creatures represent temporary art installations that gradually fade over hundreds of millions of years. The stellar tails slowly disperse as their constituent stars drift apart under their own gravitational influences. Future astronomers will witness entirely different cosmic creatures. Ongoing galaxy collisions will create new gravitational masterpieces from the wreckage of these temporary stellar sculptures. Sometimes cosmic adoption happens so gradually that nobody notices until the paperwork is nearly complete. Right now, in our own galactic backyard, the Large Magellanic Cloud undergoes a 50 billion year adoption process. Our Milky Way slowly but inexorably claims this cosmic orphan as its newest family member. This represents galaxy collision in ultra-slow motion, so gentle it makes traditional mergers look like cosmic car crashes. The Large Magellanic Cloud currently orbits our galaxy at a respectful distance of 160,000 light-years. It maintains its dignity as an independent stellar community while gradually succumbing to our galaxy's overwhelming gravitational hospitality. Unlike dramatic head-on collisions that create spectacular stellar fireworks, this cosmic adoption proceeds with the patience of geological processes. The timeline spans dozens of galactic rotations. Our galaxy's adoption strategy operates through relentless gravitational kindness rather than violent conquest. Each time the Magellanic Cloud completes its 1.5 billion year orbit around the galactic center, it loses a little more momentum. That momentum is lost to gravitational friction. The cosmic social worker in this adoption process is our galaxy's massive dark matter halo. It slowly but surely draws the wandering galaxy deeper into our gravitational family structure. Astronomers can observe this cosmic adoption in real time through the Magellanic Stream. A trail of gas and stars stretches across 200 degrees of sky. It marks the Large Magellanic Cloud's gradual surrender to our galaxy's gravitational embrace. This cosmic breadcrumb trail represents material being slowly stripped away during the adoption process, like cosmic moving boxes being unpacked one stellar neighborhood at a time. The adoption timeline extends far into the cosmic future. Computer models predict the Large Magellanic Cloud will require roughly 5 billion years to complete its integration into our galactic family structure. By cosmic coincidence, this adoption will finalize shortly after our collision with Andromeda galaxy. This creates a cosmic family reunion that combines 3 distinct galactic bloodlines into a single massive stellar metropolis. The Large Magellanic Cloud represents one of the last independent galactic communities within our local group. Most other dwarf galaxies have already been adopted by larger galactic families or scattered into intergalactic exile. Welcome to the universe's premier insect collection. The famous antenna galaxies are NGC 4038 and 4039. They display cosmic feelers that extend farther than most galaxies measure edge to edge. These aren't decorative cosmic appendages. They're gravitational antennae that sense conditions across hundreds of thousands of light years. Their host galaxies engage in slow-motion gravitational combat. The cosmic antennae form through purely gravitational sculptural processes during the galaxy's first close encounter, roughly 600 million years ago. Tidal forces stretched stellar material from both galactic participants into symmetric streaming tails. These now reach 350,000 light-years from the collision center. These cosmic insect antennae contain enough stellar material to build dozens of galaxies the size of our own Large Magellanic Cloud. Each cosmic antenna houses millions of individual stars that got flung away from their original galactic homes during the gravitational encounter. These stellar refugees continue burning nuclear fuel while traveling through intergalactic space at hundreds of kilometers per second. They represent some of the loneliest stellar communities in the universe. Cosmic nomads forever separated from organized galactic society. The antenna galaxies earned their nickname through more than just visual resemblance to cosmic insects. Radio telescopes reveal that these gravitational antennae actually function like cosmic sensory organs. They detect gravitational influences across vast distances and respond to cosmic environmental changes. The stellar streams help dissipate orbital energy during the collision. They serve as gravitational shock absorbers that prevent the merger from happening too rapidly. Ground-based telescopes show only the brightest portions of these cosmic antennae, but space-based observations reveal their true enormous scope. The Hubble Space Telescope captured faint stellar streams extending far beyond what Earth-based instruments can detect. These cosmic appendages represent some of the largest coherent structures created by individual galaxy collisions. Gravitational sculptures that rival entire galactic diameters. The cosmic insect collection will continue evolving as the antenna galaxies progress through their billion-year collision timeline. Computer simulations predict the dramatic antennae will gradually fade as the stellar material disperses into intergalactic space. Future cosmic entomologists will witness different collision phases that create entirely new insect morphologies from the same gravitational encounter. Forget simple two-partner cosmic dances. Stephen's quintet presents the universe's most complex gravitational choreography. 5 galaxies attempt simultaneous cosmic ballroom dancing in a performance that makes human group coordination look embarrassingly simple. This cosmic dance troupe has been rehearsing their gravitational routine for hundreds of millions of years. Yet they still can't seem to get their cosmic timing synchronized. The gravitational choreography involves participants with dramatically different cosmic experience levels. 4 of the quintet members dance together at roughly the same cosmic distance. They maintain relatively coordinated movements despite their obvious gravitational clumsiness. The 5th galaxy crashed this cosmic party from a completely different distance. It creates a gravitational interloper that disrupts every attempt at organized cosmic choreography. Each dancer brings unique gravitational personality traits to this cosmic performance. NGC 7317 and NG 7318 waltz together in a tight gravitational embrace. In GC 7318, B attempts an elegant solo routine while maintaining loose coordination with its cosmic neighbors. In GC 7319 hosts an active supermassive black hole that adds explosive percussion to the cosmic soundtrack. The gravitational interloper NGC 7320 photobombs every cosmic photograph while maintaining its own completely independent dance rhythm. The cosmic dance floor spans roughly 300,000 light-years from edge to edge. This provides plenty of space for these gravitational dancers to avoid stepping on each other's cosmic toes. Yet somehow they constantly manage to create gravitational interference patterns that send stellar material streaming in all directions. It's like watching cosmic bumper cars choreographed by dancers who learned their moves from completely different gravitational instruction manuals. Radio telescopes reveal the cosmic soundtrack accompanying this gravitational performance. Shock waves from multiple simultaneous gravitational encounters create radio emissions detectable across intergalactic distances. The cosmic dance generates enough gravitational energy to trigger massive star formation bursts throughout all participating galaxies simultaneously. Each dancer contributes to a cosmic orchestra that plays gravitational music audible only to radio astronomers. Most remarkably, this cosmic dance troupe will eventually achieve perfect gravitational synchronization through pure persistence in physics. Computer simulations show all quintet members gradually settling into a single massive elliptical galaxy over the next few billion years. Their current gravitational chaos represents the rehearsal phase for an eventual cosmic performance that will achieve perfect unity through complete gravitational merger. Some cosmic collisions achieve such perfect aim, they create gravitational masterpieces that look like they were designed by cosmic architects with supernatural precision. The Cartwheel Galaxy represents the universe's ultimate example of galactic marksmanship. A direct hit so perfectly centered. It created concentric rings that span 150,000 light-years. They look exactly like cosmic target practice results. This cosmic bullseye formed when a smaller galaxy hit through the center of a larger spiral galaxy roughly 400 million years ago. The gravitational impact created shock waves that rippled outward through the target galaxy like cosmic tsunamis. These waves compressed interstellar gas into dense rings that triggered massive star formation at specific distances from the collision center. It's the gravitational equivalent of dropping a cosmic pebble into a galactic pond. The resulting ring structure displays mathematical precision that would impress any cosmic engineer. The outer ring spans 150,000 light-years in diameter and contains enough newborn stars to outshine our entire Milky Way galaxy. The inner ring sits exactly where gravitational mathematics predicts. It was created by a secondary shock wave that reflected back from the galaxy's central regions. These cosmic rings maintain nearly perfect circular symmetry despite being sculpted by gravitational chaos. The projectile galaxy responsible for creating this gravitational masterpiece remains visible in Hubble Space Telescope images. The cosmic marksman sits roughly 250,000 light-years away from its target. It's still moving away from the scene of its perfect gravitational crime. Astronomers can literally see both the cosmic bullet and the gravitational wound it created in the same photograph. The Cartwheel Galaxy's ring structure represents a temporary cosmic art installation that will gradually fade over hundreds of millions of years. Computer simulations show the rings slowly dispersing as stellar orbits randomize under ongoing gravitational influences. The cosmic bullseye pattern will eventually evolve into a more conventional elliptical galaxy structure. This erases evidence of the original perfect cosmic marksmanship. This cosmic target practice demonstrates how galaxy collisions can create temporary structures unlike anything possible through normal galactic evolution. Ring galaxies like the Cartwheel represent some of the rarest galactic architectures in the universe. They require such precise collision geometry that astronomers have identified fewer than 100 examples throughout the entire observable cosmos. We're witnessing cosmic marksmanship that occurs roughly once per billion galaxies. Manhattan houses roughly 8 million people packed into 23 square miles of urban density. That makes it one of Earth's most crowded metropolitan areas. Now imagine a cosmic city 2,000 times larger than our entire galaxy that contains 6 trillion stars instead of 8 million people. Meet the universe's true urban planning champions. These elliptical galaxy megacities emerge from multiple galactic mergers over billions of years. They create stellar empires that house up to 100 trillion residents in cosmic urban areas spanning 300,000 light-years. Gravity and time work together as the universe's most ambitious city developers. They construct galactic metropolises so massive they make our Milky Way look like a cosmic small town. Meet M87. The cosmic equivalent of Manhattan scaled to astronomical proportions. This galactic megacity sits at the heart of the Virgo cluster like a cosmic downtown district that dominates its entire metropolitan region. The gravitational influence of M87 extends across millions of light-years. This makes it the undisputed cosmic mayor of our local galaxy cluster neighborhood. These cosmic megacities didn't achieve their massive scale through normal galactic reproduction. Instead, they represent the ultimate products of galactic cannibalism. Cosmic urban development through systematic acquisition of smaller galactic neighborhoods. M887 has been systematically absorbing dwarf galaxies for billions of years. It grows its stellar population through cosmic gentrification on an astronomical scale. The architecture of these galactic megacities follows predictable cosmic urban planning principles. Dense stellar business districts cluster near the galactic center. Supermassive black holes weighing billions of solar masses serve as cosmic central business districts. Stellar suburbs spread outward in all directions. They house older stellar populations in stable orbital neighborhoods that extend for hundreds of thousands of light years. Their central supermassive black holes operate like cosmic municipal services. They provide gravitational infrastructure that keeps the entire stellar metropolitan area functioning smoothly. The black hole at M87's center outweighs our Sun by 6.5 billion to 1. This makes it massive enough to anchor stellar neighborhoods across distances comparable to our entire local group of galaxies. These elliptical galaxy empires represent the cosmic real estate market's most successful development projects. They will remain stable stellar metropolises for hundreds of billions of years, long after smaller galaxies have faded into cosmic insignificance. Computer simulations reveal that our own galaxy merger with Andromeda will create a much more modest cosmic city compared to these galactic megapolises. Our future Milky Way galaxy will house roughly 600 billion stars. Impressive by local standards, but barely qualifying as a cosmic suburb compared to the universe's true galactic empires. Florida attracts millions of retirees seeking peaceful communities where they can enjoy their golden years without the chaos of urban life. The universe operates similar retirement destinations for elderly stellar populations. Elliptical galaxies where stellar reproduction has essentially shut down permanently. These create cosmic nursing homes populated almost entirely by elderly red stars living out their golden years in gravitational peace. These red and dead galactic communities represent what happens when galaxy collisions consume all the raw materials needed for cosmic population growth. The transition from cosmic fertility to galactic menopause happens during the merger process itself. Galaxy collisions trigger massive starburst episodes that consume gas supplies hundreds of times faster than normal stellar reproduction rates. It's like cosmic communities going through rapid baby booms. They exhaust their entire capacity for future population growth within just a few 100 million years. Once the galactic gas supply gets depleted, stellar reproduction essentially stops forever. Without cold interstellar gas clouds to gravitationally collapse into newborn stars. These cosmic retirement communities must rely entirely on their existing stellar populations. The galaxies become cosmic time capsules preserving stellar neighborhoods that formed billions of years ago during their last reproductive phase. The demographic transition creates galactic communities dominated by elderly red stars that have exhausted their nuclear fuel supplies and settled into cosmic retirement. These stellar senior citizens burn fuel so slowly they can maintain their energy output for hundreds of billions of years. The cosmic retirement communities will outlast virtually every other type of galactic neighborhood through pure stellar longevity. Astronomers can identify these cosmic retirement communities by their distinctive reddish colors and lack of ongoing star formation activity. The elderly stellar populations produce light heavily weighted toward the red end of the spectrum. This creates galactic neighborhoods that glow like cosmic embers rather than blazing like stellar fireworks. These represent some of the most peaceful cosmic environments in the universe. They typically contain the universe's most massive stellar populations, despite their complete lack of cosmic fertility. The merger process that shut down star formation also combined multiple galactic communities into single massive cosmic cities. These stellar retirement homes often house trillions of elderly stars spread across hundreds of thousands of light years. The cosmic demography creates galactic neighborhoods where stellar crime rates approach zero and gravitational stability reaches maximum levels. Without energetic young stars producing violent supernova or massive stellar populations creating gravitational chaos, these retirement communities offer the universe's most predictable living conditions. They also offer the safest cosmic living conditions. Modern art museums showcase sculptures and paintings that deliberately violate traditional artistic conventions. The universe maintains its own avant-garde gallery. Collision-born irregular galaxies display cosmic architecture so bizarre they make traditional spiral and elliptical galaxies look boringly conventional. These gravitational masterpieces break every rule in the Cosmic Architectural Handbook. They create stellar neighborhoods that challenge astronomers' basic understanding of how galaxies should be organized. The Cosmic Modern Art Collection features galactic sculptures that achieve their unusual forms through gravitational trauma, rather than conventional cosmic architecture. Some irregular galaxies display multiple stellar nuclei scattered throughout their structure like cosmic abstract paintings. Others stretch into elongated cosmic ribbons that span hundreds of thousands of light-years without any obvious organizational center. Take the cosmic sculpture known as NGC 4027A. It is a galaxy so thoroughly scrambled by gravitational encounters that it resembles cosmic silly putty stretched into impossible shapes. This galactic modern art piece displays active star formations scattered randomly throughout its structure. It is not organized into predictable spiral patterns or smooth elliptical distributions. It's like cosmic graffiti spray painted across intergalactic space. The gravitational sculpting process creates cosmic art through pure mathematical beauty operating under extreme conditions. Multiple galaxy encounters can stretch, compress, and twist stellar material into configurations impossible through normal galactic evolution. These represent cosmic masterpieces created by gravitational forces operating as cosmic artists. They have billions of years to perfect their sculptural techniques. Some irregular galaxies achieve such bizarre architectures they require entirely new astronomical classification systems. Ultra-compact dwarf galaxies pack stellar densities comparable to globular clusters into structures hundreds of times larger. These cosmic anomalies likely represent the stripped cores of normal galaxies that survived violent collision encounters. They create galactic fossils that preserve evidence of ancient gravitational catastrophes. The Magellanic Clouds represent our closest examples of collision-induced cosmic modern art. Both galaxies display irregular structures created by gravitational encounters with our Milky Way galaxy across billions of years. Their chaotic stellar arrangements and active star formation regions create cosmic abstract paintings. These are visible to naked eye observers in Earth's southern hemisphere. Perhaps most remarkably, these cosmic modern art pieces often display more active star formation than conventional galactic architecture. The gravitational chaos that creates irregular structures also compresses interstellar gas clouds beyond normal density thresholds. This triggers massive stellar reproduction bursts that illuminate these cosmic sculptures with brilliant newborn stars. The universe's most chaotic galactic art often produces its most spectacular stellar fireworks displays. These gravitational masterpieces represent temporary installations that gradually evolve toward more conventional galactic architectures over cosmic time. Future astronomers will witness entirely different cosmic modern art. Ongoing gravitational encounters will create new irregular galaxies, while existing cosmic sculptures settle into more traditional galactic retirement communities. Imagine a construction company with the patience to work on building projects for 13.8 billion years. This company gradually assembles today's massive galactic skyscrapers from countless smaller cosmic building blocks. That's exactly how the universe's most successful development firm has been operating since the cosmic dawn. Galaxy Collisions Incorporated has been transforming tiny galactic villages from the early universe into today's massive stellar metropolises. In cosmic prehistory, the universe looked like a suburban development gone wild. Billions of small galaxies scattered throughout space. Each contained only a few million stars compared to today's galactic giants. These cosmic starter homes represented the universe's first attempt at galactic architecture. But they were destined to become building materials for something far grander. The cosmic merger and acquisition process began almost immediately after the first galaxies formed. Gravity served as the ultimate corporate raider. It systematically combined smaller galactic companies into progressively larger cosmic conglomerates. Each merger added stellar assets and dark matter real estate to create increasingly dominant galactic corporations. These corporations could acquire even more cosmic territory. Computer simulations reveal this cosmic construction timeline with stunning precision. Start with the actual distribution of matter in the early universe. Let gravitational corporate mergers operate for 13.8 billion years following known physics. The result matches today's galactic corporate landscape remarkably well. It is a cosmic economy dominated by massive galactic conglomerates like our Milky Way that absorb dozens of smaller competitors. Our own galaxy represents a classic cosmic success story built through strategic acquisitions. Astronomical archaeology reveals evidence of multiple galactic mergers in our stellar fossil record. Different stellar neighborhoods preserve chemical signatures from distinct galactic companies that got absorbed billions of years ago. The Milky Way's current stellar population represents a cosmic melting pot of acquired galactic assets. The cosmic construction industry continues operating at full capacity throughout the universe. Right now, thousands of galactic mergers are adding new stellar real estate to existing cosmic corporations. Each successful merger creates larger, more stable galactic enterprises. These enterprises become capable of surviving in an increasingly competitive cosmic marketplace dominated by ever larger gravitational conglomerates. This cosmic construction boom won't last forever. Universal expansion will eventually stretch distances so far that even the most aggressive galactic corporations can't reach new acquisition targets. But for now, Galaxy Collisions Incorporated continues building the universe's most impressive architectural projects through the patient accumulation of cosmic assets across geological time. Galaxy collisions operate as the universe's most productive heavy metal factories. They supercharge the cosmic assembly lines that manufacture the essential elements needed for planetary systems and biological life. Without these gravitational production boosters, the cosmos would remain a cosmic wasteland. A universe populated only by hydrogen and helium, the cosmic equivalent of a kitchen stocked with nothing but salt and water. The cosmic manufacturing process requires massive stellar production facilities to create elements heavier than hydrogen and helium. Individual stars serve as nuclear furnaces that gradually cook lighter elements into progressively heavier cosmic ingredients. But this stellar cooking happens so slowly. Most galaxies would require hundreds of billions of years to produce sufficient heavy elements for complex cosmic chemistry. Galaxy collisions dramatically accelerate this cosmic manufacturing timeline through industrial-scale production increases. The collision-triggered starbursts create hundreds of times more stellar factories than normal cosmic conditions allow. Each newborn massive star functions like a cosmic pressure cooker. It rapidly converts hydrogen and helium into carbon, oxygen, silicon, and iron within just a few million years of stellar operation. The cosmic production line reaches maximum efficiency when massive stars complete their manufacturing cycles through spectacular supernova explosions. These stellar factories don't just shut down. They detonate like cosmic grenades. They scatter their heavy element products across entire galactic neighborhoods. Galaxy collisions trigger so many simultaneous stellar explosions, they create industrial-level heavy element distribution networks. Astronomical evidence reveals this cosmic manufacturing boom in stunning detail. Galaxies caught in the middle of collision-triggered starbursts show heavy element concentrations far exceeding normal cosmic production levels. These collision zones represent the universe's most productive heavy metal foundries. They create cosmic raw materials at rates that dwarf isolated galactic production capabilities. The implications for cosmic life extend far beyond simple element production. Without collision-enhanced heavy element manufacturing, most cosmic neighborhoods would lack sufficient raw materials for rocky planet formation. The complex chemistry required for biological life demands access to cosmic ingredient lists. Only collision-accelerated stellar production can provide that within reasonable cosmic timeframes. Our own solar system benefits directly from this collision-enhanced cosmic manufacturing heritage. The heavy elements that comprise Earth's rocky composition were forged in stellar factories that operated billions of years ago. This happened during the Milky Way's own collision-triggered starburst episodes. Every carbon atom in your body, every oxygen molecule you breathe, represents cosmic manufacturing products created through galaxy collision industrial processes. Galaxy collisions create a cosmic reproductive paradox that would puzzle any universal fertility specialist. These gravitational encounters dramatically increase stellar reproduction rates, but they simultaneously make planetary system formation much more difficult for future generations. The cosmic baby boom that creates millions of new stars also destroys the calm galactic nursery conditions that baby planets need for successful conception. Planet formation requires cosmic bedroom conditions so delicate they make human fertility look robust by comparison. Baby planets need stable stellar neighborhoods where newborn stars maintain consistent energy output for millions of years. There can't be gravitational interference from cosmic neighbors. The dusty disks around young stars must remain undisturbed long enough for cosmic conception to progress from dust grains to planetary embryos. Galaxy collisions completely disrupt these cosmic fertility requirements. The gravitational chaos scrambles stellar orbits so dramatically that newborn stars rarely maintain the stable neighborhood conditions needed for successful planetary reproduction. Gravitational encounters with cosmic neighbors can scatter planetary formation materials before baby planets achieve sufficient size for gravitational independence. The collision-triggered starburst environments create additional cosmic fertility challenges through excessive stellar radiation. Court. When millions of massive stars ignite simultaneously in dense cosmic neighborhoods, their combined energy output sterilizes surrounding regions through deadly ultraviolet bombardment. The cosmic radiation levels become so intense they photoevaporate the dusty disks needed for planetary conception. Elliptical galaxies, the typical products of major galaxy collisions, represent cosmic environments particularly hostile to planetary reproduction. These stellar retirement communities lack the organized spiral structure that creates stable star-forming regions needed for successful planetary family planning. Most elliptical galaxy residents live in chaotic three-dimensional neighborhoods where gravitational interactions constantly disrupt planetary formation attempts. Astronomers observe this cosmic fertility crisis throughout the universe. Surveys of planetary systems reveal that elliptical galaxies contain far fewer successful planetary families compared to spiral galaxies with stable stellar neighborhoods. The collision process that creates massive stellar populations simultaneously reduces their capacity for cosmic reproduction through planetary formation. This cosmic fertility trend has profound implications for the distribution of life throughout the universe. As galaxy collisions gradually transform spiral galaxies into elliptical stellar retirement communities, the cosmos becomes increasingly hostile to new planetary system formation. Future civilizations will inherit a universe where successful cosmic conception becomes progressively more difficult despite abundant stellar populations. Cosmic social distancing is about to become a permanent universal policy. In roughly 100 billion years, the accelerating expansion of space will stretch distances between galaxy groups so far, even gravity will finally give up trying to arrange cosmic get-togethers. This marks the beginning of the universe's permanent transition from cosmic community to eternal galactic isolation. The cosmic loneliness epidemic results from dark energy's relentless campaign to separate everything from everything else. This mysterious cosmic force drives universal expansion at ever-increasing rates. It gradually overwhelms even the strongest gravitational attractions between galactic neighbors. What begins as cosmic social distancing will evolve into permanent intergalactic quarantines spanning infinite time. Computer models reveal this cosmic social timeline with depressing precision. Galaxy groups currently bound by mutual gravitational attraction will spend the next 100 billion years gradually losing their capacity for cosmic community interaction. The local group containing our Milky Way, Andromeda, and dozens of smaller galaxies will complete its final merger projects. This will happen just as universal expansion makes contact with other galaxy groups impossible forever. The transition from cosmic community to galactic isolation happens gradually. Then suddenly, galaxy clusters will maintain their internal social structures for hundreds of billions of years while losing contact with neighboring cosmic communities. Eventually, even these local galactic neighborhoods will succumb to universal expansion. Individual galaxies become cosmic hermits separated by distances that make current intergalactic space look crowded. This cosmic loneliness epidemic represents the universe's transition from social adolescence to isolated old age. The current epoch, featuring ongoing galaxy collisions and active cosmic community interactions, represents peak social activity in the universe's long-term social calendar. Future civilizations will inherit a much lonelier cosmos where galactic neighbors become unreachable across distances that expand faster than light itself. The implications for cosmic civilization extend far beyond simple galactic geography. Advanced civilizations hoping to expand beyond their home galaxy groups must complete their cosmic colonization projects within the next 100 billion years. After universal expansion wins the ultimate cosmic tug-of-war, intergalactic travel becomes physically impossible regardless of technological advancement. Yet this cosmic loneliness epidemic also represents a form of cosmic preservation. The galaxy groups that complete their internal mergers before universal expansion takes over will remain stable cosmic islands for hundreds of trillions of years. These galactic hermitages will provide safe cosmic neighborhoods for civilizations that achieve successful local community development before the universe enforces permanent cosmic social distancing. Picture the universe's ultimate retirement community after all the construction projects end and all the neighbors move away. A cosmic twilight zone populated by ancient elliptical galaxies. They slowly fade into darkness as their elderly stellar residents gradually exhaust their nuclear fuel supplies. This represents the final chapter in the galaxy collision story. Cosmic construction projects give way to gentle cosmic decay spanning hundreds of trillions of years. The cosmic retirement timeline unfolds with geological patience across timescales that dwarf current cosmic age. After the last galaxy collision completes roughly 100 billion years from now, the universe will enter its longest and most peaceful phase. The surviving elliptical galaxies will house enormous stellar populations that gradually dim as their nuclear furnaces run out of fuel. Red dwarf stars, the cosmic equivalent of efficient economy cars, will dominate these galactic retirement communities through sheer longevity, while massive stars burn out spectacularly within millions of years. These stellar seniors consume fuel so slowly, they can maintain their energy output for trillions of years. The universe's twilight era will feature cosmic neighborhoods illuminated primarily by dim red stellar streetlights. The cosmic retirement process operates like the world's most gradual sunset spanning geological time. As stellar populations age, galactic neighborhoods become progressively dimmer and redder. The brilliant spiral galaxies that dominate today's cosmic landscape will be remembered only through fossil evidence preserved in elliptical galaxy archives. The universe transitions from cosmic daylight to eternal twilight. Cosmic archaeologists studying these ancient galactic retirement communities will discover fossil evidence of the collision-driven construction boom that created their stellar metropolises. Chemical signatures preserved in stellar populations will reveal merger histories spanning billions of years. Each elliptical galaxy will serve as a cosmic museum, preserving evidence of the gravitational construction projects that built the universe's largest architectural achievements. The cosmic twilight era will also feature the gradual dissolution of these galactic retirement communities through stellar evaporation. Random gravitational encounters between elderly stellar residents will occasionally accelerate individual stars beyond escape velocity. Over hundreds of trillions of years, even the most massive elliptical galaxies will slowly lose their stellar populations to intergalactic exile. Eventually, the cosmic retirement communities will fade so completely that the universe becomes dominated by isolated stellar hermits wandering through expanding darkness. The galaxy collision epoch, featuring spectacular stellar construction projects, dramatic gravitational architecture, and cosmic community interaction, will exist only as ancient history. It is preserved in the fading memories of the universe's last elderly stellar residents. Yet this cosmic twilight scenario represents peaceful conclusion rather than catastrophic ending. The universe's transition from vibrant cosmic construction to gentle stellar retirement span scales so vast. They provide ample opportunity for civilizations to develop, flourish, and achieve cosmic significance. This happens before the final cosmic sunset begins. The galaxy collision era represents cosmic youth and middle age, the universe's most productive and energetic period before settling into eternal cosmic retirement.